Okay, so in this presentation, we're going to be looking into natural dyes and kind of looking into how they are traditionally made, specifically indigo and how it gets specifically made, and kind of looking at the science behind it and why dyes are made the way that they are and what qualities these plants have within them that make them better choices for using as dyes, especially for natural dyes. So the way that I'm going to kind of go through this is looking into pH because pH actually impacts the way that indigo gets drawn out of its leaves and how it gets its actual color, which I'll discuss a little bit later on in the slideshow. So that's why I'm first introducing that. And then I'm going to kind of walk through the process of making natural dye. And yeah, that's kind of the idea. So basically, the pH scale is a measure of how acidic or basic something is. It ranges from 0 to 14, with 7 being neutral. Anything above a 7 is considered to be basic, and anything below it is considered to be acidic. And so another word for basic is alkaline. So that's something to keep note of because that's going to come up again later on. And so for reference, bleach is something that's very basic. So it would have a high pH, whereas battery acid is very acidic, so it would have a pretty low pH. So it's technically the measure of the amount of free hydrogen and hydroxyl ions there are. And so the more free hydrogen ions, the more acidic something is, whereas the more hydroxyl ions, the more basic something is. And so the equation listed there just kind of shows how pH is the negative logarithm of the hydrogen ion concentration. So the pH balance of dyes. So the fermentation vats that are necessary for drawing out the most potent versions of the dye do not require high alkalinity. So an alkaline has to have a pH above a 7, so it's technically basic, but it doesn't actually need to be that high to draw out those colors. The process only requires a pH between about 9 or a 10. And so some sources of alkaline that you can find are calcium hydroxide, hardwood ash, and lye. And so when the fermentation begins, pH decreases. And so if you can see on the graph on your right that it shows that as the pH goes down, the pH goes down with time. All right, so after the intro to pH, we're looking at making natural dye. So traditionally, dye was made by the artisans who would practice batik. They would make their own dye and they would use resources that they had from their local area. So some of the most popular dyes most popular natural dyes that are used are chestnut, henna, indigo, Brazil wood, and lac. Each of them obviously come in different colors, but it's also very dependent on where you live, and what vegetation grows within your area, because that will kind of define the color schemes of your batik. So I kind of looked into what makes a good natural dye, and there's some pretty obvious ones. Like clearly the most important thing about a good natural dye is high pigmentation. The more pigmented, the more likely, or the brighter the clothing will be, the longer it'll hold. Well, it won't necessarily hold, but the more pigmented it is, the better it'll look. So that's number one. But a few other factors that contribute to making a good natural dye is having to be non-toxic. There's actually a few dyes out there that still have, I'm blanking on the name of the toxic material that's used in them. I literally read it yesterday on the dye box to make sure I didn't get any of my roommates sick. But there is a few things that could be put into the dye that are typically no longer used, but they can actually make you really, really sick or kill you. So definitely good to have a non-toxic dye. And also obviously the ability to hold on to fabric. So if it washes out really easily, if it fades in the sun, you want it to be able to hold on for as long as possible. You want it to basically be a stain. And solubility kind of relates to that, where if you put it through the wash too many times, is it just going to disappear on you? You want to make sure that you have one that will actually remain for long periods of time. You don't want all of your clothes fading immediately. So the dye that we're going to look at specifically is indigo. And the reason why I picked this one is because it is one of the most popular plants to use for a natural dye. It's because it produces a wide range of blues. And so that range can go from light blue to an almost black navy blue. So it's really, really versatile. So it's definitely a very interesting one to explore. So indigo is, once again, one of the most popular dyes to use, just mainly due to its depth of color, its wide range. And so it's mainly produced or it's mainly used in the production of denim. So most jeans use indigo to get that classic blue jean look. So the main component that causes the coloration is indican. We'll talk about how you derive indican from an indigo leaf, but it is stable in the plant since it's attached to glucose, which forms indican glucose. So in the next slides, we're going to talk about the breakdown of that compound. And so within the indigo plant, it contains about 0.2 to 0.8 of the indican glucose. All right, so looking at this process, indigo is harvested prior to cutting or prior to the flowering. So they cut it really short. And then after that, it is placed into a tank and weighted down with rocks. And it's left in that water to ferment for some time. And so this natural fermentation process is called vatting, and it's basically just a reduction process. All right, so to look at the fermentation process, when the leaves are fermented, indican is hydrolyzed. So if you looked at the image above, that is I'm just going to go back a slide. That would be called the indican glucose. I'm spacing on the name. So that would be the indican glucose, and it breaks down into indroxyl and glucose. So when the leaves are fermented, it's hydrolyzed. So it gets, water comes in, breaks it into these two. And so indican splits into indoxyl and glucose by indoxylase. And so the enzyme glucosidase is present in the leaves, which is causing indoxyl to come out. And at the same time, microorganisms are generating hydrogen as a reducing agent, making the dye water soluble. And so to go a little bit more into this and relate it back to those pH slides that I brought up in the beginning. So regardless of the type of plant, the leaves or the flowers of that plant must be soaked in alkaline water. So in that first slide, when I said that they got put into a tank, that tank also has alkaline in it. And it would be somewhere within that 9 to 10 pH level range. And the reason why this happens is so during the extraction and hydrolysis of indican is a glycoside, and it breaks down into glucose and indoxyl. And once again, hydrolysis occurs thanks to the microbes. And so the reason why there needs to be alkaline in there is because interactions between indoxyl and the oxidizing agent, which is typically air, the way that it traditionally happens is people will stir the vat every once in a while to incorporate that air into the dye. And so when that happens, when there's interactions between the indoxyl and the oxidizing agent, under a condition where there's high pH levels, so the high pH levels being above a 7, so alkalinity, so any like a pH above 7, it yields the active pigment in indigo dye, which is indigotin. And so you need to have that basic element in order to trigger the dye to come to fruition. And so continuing on with this process after the fermentation, indigo white salt, it's this yellow liquid. It's kind of gross looking, as you can see in the image. It's a yellow liquid and a blue foam, and it forms on top after about 12 to 15 hours of this fermentation. And then the runoff after that gets put into another tank where it gets oxygen incorporated by paddle wheel. So that's what I meant with the oxidation process. And then the next note says this oxidizes the reduced indigo into proper dye. And so by proper dye means that the air is causing the indigotin to come out and allows the dye to be as potent as it is. So the settled indigotin is transferred to yet another tank, and the third process at this point, and is heated to halt the fermentation process. And so at this point, the dye is basically this big blue flaky mass, and it gets boiled with water, filtered until it's a paste. It gets pressed, and then it gets cut into pieces. And so you can kind of see on the image just chunks of dried indigo dye. And it takes roughly 100 kilograms of indigo to create only 1.5 to 2 kilograms of dye. And that's it. So yeah, that's kind of the general process. But